Welcome to EDU World Space.
We're asked to find the moment about this AD rod, given that the tension of the BH cable is 450 newtons. And I went ahead and found the position vectors of the different positions on the figure. So to start with, I'm going to write out the formula for the moment of the AD rod. So that's going to be equal to the unit vector of the AD rod dot the AB vector cross the tension vector of the BH cable. So to start with, we're gonna find this term first. So we need to first find the AD vector. So AD vector, that's gonna be equal to D vector minus A vector, and that'll give us a vector of 1i minus 0.75k. And to find our unit vector AD, that's going to be equal to the A vector, the AD vector, divided by its magnitude. So 1 squared plus negative 0.75 squared under the square root, and that will give us a unit vector of 0.8i minus 0.6k. And next we're going to find this AB vector. So to get AB vector, we do B vector minus A vector, and this will give us a vector of 0.5i. And lastly, we're going to find this tension vector. So we need to first find the BH vector. So BH vector, it's going to be equal to the H vector minus B vector, and that will give us a vector of 0.375i plus 0.75j minus 0.75k. And we can now find the tension vector. So the tension vector of the cable BH, that's going to be equal to the magnitude of the force of the tension. So it's given as 450 times this BH vector divided by the vector's magnitude. And this will give us a vector of 150i plus 300j minus 300k. And we now have everything to plug into this formula. So the moment of AD, the moment about the AD rod, that's going to be equal to the unit vector of the AD rod. Dot the AB vector cross the tension vector. And we can write out this expression as a matrix. So this is equal to the determinant of this vector in the top row, the unit vector, the AB vector in the middle row, and the tension vector in the bottom row. And solving this matrix will give us a final answer of -90 Newton meters.